Hi guys, we're back. Yep, this is Mrs. Uy, and I'm with.
And I'm Miss Gray.
Yeah.
Yep, you've seen our faces plenty of times before.
Yes.
So today let's work on dimensional analysis and
T-tables. Podcast 2.7. This is the last podcast for Unit 2.
Yes. And honestly, once you master this, your life is going to be so much easier. T-tables are going to save you a lot of work in the long run.
Yes, exactly.
All right, so work really hard and practice until you get it right. And not enough practice to get it right. Practice until you can't get it wrong. That's my advice.
Oh, yes, that's a good advice.
Okay, let's start with dimensional analysis.
Okay.
What we mean by this is using the units to help us figure out the answer to the problem. So you got to know what units match with what quantities.
Yes.
Right?
And we need the help of a conversion factor.
Yes. If you want to change units from one to another, then you use what's called a conversion factor. And it's simply a statement that's equal to 1.
Yeah.
So we're going to see, how do we get something that's equal to 1? Well, anything divided by itself is equal to 1. Okay, so let's look at this. Would you agree that 60 minutes is the same thing as 1 hour?
Yes.
Then, if it's the same thing, then 60 minutes over 1 hour is a number divided by itself.
Yes.
So that's equal to 1. So we can use that as a conversion factor.
Yeah.
And 1 over 1 is equal
to 1.
Yeah. So we can flip it upside down.
Yes.
Because it won't change the quantity. So that's why conversion factors are useful to us.
Yes.
They're reversible. So you can get whatever result you need.
Yeah.
Yeah, so that's how we use dimensional analysis. If we're going too fast, just push pause on the podcast
and
rewind and listen to it again.
That's the beauty of this thing.
Right.
All right.
Okay, so in conversions, we're going to use what's called a T-table. Okay, that means like a little ladder where we have sections here.
Yeah,
a T-table.
Looks like a T.
And we use it to convert between different units because it helps us stay organized.
Yeah.
Okay. And here's an example.
Okay.
We're going to change 150 centiseconds to seconds. So I want you to circle your target. We're going 2 seconds. That's our target.
That's one of the base unit, yeah?
Yes.
In King Henry,
yes.
The ladder.
Right. And we are starting with 150 centiseconds. So I always underline my starting place because he's going to go on the starting line of my T-table.
Yes.
All right? Just like a race begins on the starting line.
Of course.
So I put 157 centiseconds here. All right. Now let's look at our staircase.
All right.
I think I can pull it up this way. Yep. My writing's in the way. So I'm going to clear it so we can see what's going on. We need to go from centiseconds.
Yeah. To seconds.
Okay, here's centi, and here's our base units. So centiseconds to base units was 2 steps, right?
Yep.
Okay, so here's my trick. 2 steps means 10 to the second.
10 to the second.
All right, let's go back to our podcast because I want to make sure that you see how to put this together. Looks like eyeballs.
A smile.
Yeah. Okay. We're going to go 2 steps. So we start with 157 centiseconds. And if we were doing the King Henry method, we would just move our decimal twice.
Twice, yeah.
I don't want you to do that this time. I want you to put centiseconds across because crisscross cancels. The only way to cancel centiseconds is to put them diagonally across. So we have 1 to multiply, 1 to divide, and it's going to go away. We take our target and put that above it.
Yes.
And we're going from centiseconds to seconds. Which one is bigger? Seconds or centiseconds?
Of course, seconds.
Seconds, yeah, definitely. So we put the 1 in front of the larger unit.
Okay.
And in your worksheets, in your packet, you have these instructions written out.
Yes.
So follow those steps as we solve these. The 1 goes in front of the larger unit. Now I said it's 2 steps,
2
right?
steps.
So I'm going to put 10 to the second power because it's 2 steps.
2 steps.
From centi to second. So as long as you know which one's bigger, and you know how many steps to go,
yes,
then you crisscross cancel and you're good. So centiseconds goes away. Now how do we do this math? You see this line, the vertical line means multiply. The horizontal line means divide. So we'll take 157 times 1.
Is 157.
Right, we won't use our calculators for that.
No.
And then we're going to divide that number by 10 to the second.
To the second.
Okay, so now you can use your calculator if you must.
All right, I will. Clear. That's 157.
And then to get 10 to the second, remember to use the E button.
E button, yeah.
Right. And you get 1.57.
1.57.
Right. And we'll put a box around this answer because that's the way I
our
like
final
it.
answer.
Right.
All right.
Good. Let's try another one because that was our first time.
All right.
And I want to be sure that every time we do a T-table, we always use the base unit. So we're going to nanograms. We're starting with centigrams. All right. So before I scribble all over everything here to solve this, let's look at the steps. Okay.
Let's put King Henry.
All right. Let's go to the staircase. There it is. And I would just like to look at the staircase without all that mess. Is it possible? Not. Maybe.
Maybe.
Okay.
There you go.
Okay. So here's nano down here and centi over here.
Yes.
We're going centi to nano, right?
Yes.
Okay. So we're moving 1, 2,
forget the shaded
3,
one.
4, 5, 6, 7.
7 steps.
All right, 7 steps. We can do this.
All
7
right.
steps. Back to our slide. Oh, you know what? I said I wanted to use the base unit.
Oh, yeah.
Okay, so we could go 7 steps, but it's going to be easier for us to go back to the base unit.
Okay.
All right, back to King Henry. It's okay. It's a common mistake, and I made it, so now our students don't have to.
Oh, yeah.
Okay, so we'll go from centi to the base, 2, right? And you don't have to count the little hops because you've got this written in there. 10 to the minus 2
10 to the minus
means it's 2 steps away.
2 steps.
Nano is 10 to the minus 9, so it's 9 steps away from your base unit.
Yes.
All right? So you don't have to do all the little hops on all the steps of the staircase.
Okay.
You can use these to know how many steps it is from the base unit.
Okay.
All right, well now I've written all over everything. So let's go back to the slide, and I'm just going to clear all the writing. So we have a way to tell what's going on.
Okay.
Okay, so centi to base is 2 steps. 8.25 times 10 to the second centigrams, and we're going to go to our base unit, which in this case is grams.
Yes.
Always stop off at your base unit.
At your base unit.
Yeah, don't go from one prefix to another.
Okay.
Go from prefix to base. So centigrams has to go on the bottom. We're going to grams.
Yes.
That's our base unit. Which one is bigger?
Of course, grams.
Yes.
So
And then we said 2 steps to centi.
10 to 2.
And now let's keep going because this is our target.
Yeah, we're not there yet.
Yeah, so we need one more step.
Okay.
And I know that crisscross cancels. This time I'm going from grams to nanograms. So I put grams across from one another.
So you can cancel out.
I can cancel it out because I want to get rid of grams and end up with nanograms.
Yeah.
We know grams is bigger than nano. And that was 9 steps.
9 steps.
So we just put 10 to the 9. Don't put minuses. That's why I always tell you, put the 1 in front of the larger unit. That way you never have to worry about negatives.
Okay,
it's easy to mess up your math when you have negatives and fractions.
Negative is not really good sometimes.
Yeah, I make too many mistakes that way. All right, so let's remember how to do this.
Okay.
Multiply the tops. Multiply
All right.
the tops.
I'm going to start multiplying now.
Okay, so our rules with scientific notation, if you multiply, that means adding exponents. So 10 to the second and 10 to the 9 makes 10 to the 11. Okay, then we divide by what's on the bottom, which is just 1 times 10 to the second.
Yep.
Okay, when we divide in scientific notation, what do we do with the exponents?
We subtract exponent.
Okay.
I remember that.
So I didn't even need a calculator. I'm glad you're checking me. But I have...
I'm just checking, Ms. Gray.
Yeah, 11 minus 2 is 9. So 8.25 times 10 to the 9 nanograms.
Yes.
Right. That's
See,
it.
I got a lot of 0 in my calculator, Miss Gray.
Yeah, I bet you have 7 zeros.
Yeah. 2, 4, 6. Yes, you're right.
Yep, because your calculator is not set for scientific notation mode. If you wanted to change that, I could show you how, but not on this computer.
Not.
Because it doesn't have a calculator
Okay.
or simulator.
Yep.
Yeah, we'll show our students when we do the calculator lesson. But if you look here, 10 to the second cancels 10 to the second, just like centigrams cancels centigrams, and grams cancels grams. So all we had left was 10 to the 9. That's what's in our answer.
Yeah, you're right. You don't even need a calculator for that.
Yeah. So whenever possible, make the math easier. The kind of math I like to do is the math that is easy.
Easy.
Yeah. So every time I find a trick that's going to make it easier, I'm going to show it to you guys.
Thank you, Miss Gray.
You betcha.
Yeah.
I think we should do another one, though.
Okay.
These are hard, and it takes practice.
Yes.
Okay. It's just hard to know where to start.
Yeah.
Okay.
But if they're going to follow us carefully, they're going to get that.
Of course. Now we have another two-step process because now it says the radius of a potassium atom is 0.227 nanometers. We want this in centimeters. This is our target, so I will circle the target and underline what goes on the starting place.
All right.
Okay, so I have 0.227 nanometers. I know I want to put nanometers down on the bottom, so crisscross will cancel. But I don't want to go directly to centimeters.
Go to the base.
Yeah, my
base
home
is
plate,
meters.
right?
Yes.
Always go home.
Yeah, it's safe.
Yes. So let's look at our staircase.
All right.
And of course I have now written all over it. All right. Centi is here. No, we had nano.
Nano, yeah, that's the first thing. Nano.
Right. We have nano and we're going home.
We're going home.
And the last time we saw it was 10 to the minus 9 means it's 9 steps away.
9 steps.
Okay. So if we're 9 steps away, then we can use 10 to the 9 to go from nano to meters. All right.
So
which one's bigger?
Meters.
Oh, yeah, that's a lot bigger than nanometers. And we were 9 steps away from nano. Great. Now we're going from the base,
to
meter to centi.
The unit that we need, centi.
Right. So crisscross cancels, right? Those are goners. And
that's
centi was 2 steps away.
Yep.
We saw that last time.
Okay.
Okay. Well, last time we were able to cancel stuff out.
Yeah, but
I
this
don't
time...
have any of this time. So I have 0.227 times 10 to the second divided by 10 to the 9. Be careful when you're doing this division, right? 1 times 10 to the 9. Technically, here's my 1 and 10 to the 9. Subtracting these, I have 2 minus 9. So I get a negative number.
You get a negative number.
So I get 0.227 times 10 to the minus 7. And that's from the Word document. I can't leave it this way.
Yeah.
Because you didn't get the same answer as me.
No.
And here's why.
Because your answer is not final answer, Ms. Gray.
Yeah. Because I'm only allowed to have 1 digit in front of the decimal.
Yes.
So I need 2.27, and I better change my color, times 10 to the minus 6. Remember, moving to the right reduces?
Yeah.
So I need 8. Whoops, right? 10 to the minus 8?
That's what I got, Ms. Gray.
Oh, well,
2.27
times 10 to the minus 8.
Negative 8.
All right, and our units here now are centimeters. Don't forget to put units on the end.
And put box in your final answer.
Yep, there we go. So 2.27 times 10 to the minus 8. We can do this. If you use your calculator or you use math that you know how to do, I don't care which way you do it. I just care that you do it right.
Yes, and you're going to come up with the correct answer.
Yep. Okay, well, it looks like we've got another one.
More example.
Okay.
That will help us.
Yep, that's good. The diameter of Earth is a long ways. 1.3 times 10 to the 4 kilometers. Okay, now we want to go to the diameter in decimeters.
That's 1 step on there.
I think 2.
I think.
Because don't go from prefix to prefix.
Yeah.
Go home first.
Go home first.
Yep.
Yep.
All right, well, before I scribble everywhere, let's go look at the staircase. How many steps is kilo from home? Here's home.
And that's kilo right there.
Yep, here's kilo. So
pointing.
1, 2, 3. All right, because it said 10 to the third.
10 to the third.
3 steps.
All right.
And then deci is the next one over. It's 10 to the minus 1, so it's 1 step.
Oh, that's easy.
Yeah. All right.
All right.
So now we know what to put in our T table. Let's go back and do it.
So start
with what you're given.
Underline it. Do not forget.
1.3 times 10 to the 4 kilometers. And here's our target.
Yes.
I'm not going to stop until I get to my target.
8, of course.
All right, kilometers has to go across, and we're going to go home. So for kilometers, meter would be home.
Yeah.
Which one's bigger?
Kilometers.
Yes, of
Put
course.
1 in there.
So put the 1 in front of the bigger unit. And then it was 3 steps.
10 to the third.
Right. Now meters has to go catty-corner.
Yep.
Crisscross cancels. And we're changing to decimeters now. So which one is bigger?
Meters. Put
Certainly.
1 in there.
1 goes there, and it was 1 step away. So it's 10 to the first.
Yep.
Great. No negatives.
No negatives.
Yeah.
Good.
Okay. And look at our denominator. That's easy. It's just 1.
Yeah. Do I need my calculator in that? I don't think so.
No, let's not.
All right.
Let's not bother with it. So it's
Okay.
1.3, and then we're going to add the exponents. 4 plus 3 plus 1.
That's 8.
Okay. And then kilometers is a goner. Meters is a goner. This is what we're left with that matches our target.
Yep.
We are good to go. 1.3 times 10 to the
We're
8.
Done with that problem.
Yeah.
That's easy.
Yeah.
I don't even need my calculator for that.
No, but we had it there just in case.
Yes, just in case.
Yep.
This is my friend. This is your friend too.
Yep. As long as you know how to use it.
Yep. Do we have one more problem, Miss
I believe we do.
Okay.
Okay, I put this one in here for a special challenge. Okay, this question's not going to come up on the test.
I don't know if I love challenge, but I bet our students do.
I bet so. They're so clever.
Okay.
But I will put this as a bonus question somewhere.
Okay.
Okay, maybe on a worksheet or maybe on a test. Maybe even on the final.
Oh.
Yeah, okay.
I better get ready.
This is a true statement. Light travels at a speed of 3.00 times 10 to the 10 centimeters per second. That's pretty fast. Yeah. We want to know something that we can relate to.
Yeah.
Like in your car, you have on your speedometer kilometers per hour. So let's see, how fast is that in kilometers per hour? Could you go that fast in your car?
I don't think so.
I don't think so either. But let's just see.
I don't want to get a speed ticket, Miss Gray.
I don't think they'd catch you. If you were going that fast at the speed of light.
Yeah.
Okay, so we have 2 things to worry about. We go centimeters to kilometers. Okay, we don't go prefix to prefix. We got to go home first.
Go home first.
All right. And then seconds to hours.
Yes.
So we have 2 things to deal with, but we only need 1 T table. We can do it all at once.
But it's just long. T table.
Yeah. So we're going to start with what we're given. 3 times 10 to the 10 centimeters, and it says per second. That means second goes on the bottom.
Okay.
That means in 1 second you go 300, no,
I don't know. That's a
30 billion centimeters.
Okay.
Ugh,
Okay.
that's a long ways. We know we want centimeters down here. How do we get home? Go to meters.
Go to meters, yes.
Meters is bigger. How many steps was centi?
2.
Yeah, 2 steps.
10 to the 2.
Okay, 10 to the second. All right, so centimeters we've dealt with. That's gone.
But we're not there yet.
Now we got to go to kilometers.
Yes.
And I know crisscross cancels. Which one's bigger?
Kilometers.
Okay.
Put 1 in there.
And how many steps to kilo?
1, 2, 3.
All right, 3 steps to kilo.
That's according to.
Yes, use the metric mania. You better have that staircase memorized if you're not going to have it in front of you in class.
Or if not, have it in front of you.
Yeah, so bring it to class or memorize it. It's up to you.
Yes.
Yeah. All right, what's next?
Meter is meter cancel, right?
All right, good.
Okay.
So we have kilometers. That's part of our target.
Yeah.
Now.
But we're not there yet.
We got to deal with the time.
Yep.
Okay, seconds is down here. So to crisscross the seconds, I have to put it on top now.
Yes.
And I want to change it to hours. Do you want to go straight from seconds to hours? It is on your staircase paper.
Yeah.
Okay, might as well. So which one's bigger, an hour or a second?
Hour.
Yeah, lots bigger.
Yeah.
And then on your notes, it says how many seconds are in an hour. 3,600 seconds are in 1 hour.
Yes.
All right, so seconds is gone. Now I have hours on the bottom.
Yay! And we're
kilometers per hour is kilometers on top, hours on the bottom.
I think I need my calculator in this problem.
Yeah, I would. Now we take top times top. 3 times 1 times 1 times 3,600 times 10 to the 10. So
times, yep.
10 to the 10 times, I'm going to use parentheses there, 3,600. All right, and then on the bottom, every time I cross this line on the bottom, I have to multiply it. So I have 1 times 10 to the 5th on the bottom, because 10 to the 2nd and 10 to the 3rd is 10 to the 5th. Now I'm going to simplify here. 5 will cancel 5 of these.
So that's 5.
All right, I'm doing all this math in my head when I really don't need to. 3 times 3,600
is, 3 times 3,600, sorry about that, 10,800.
10,800. That's how many seconds you have every single day of your life. All right, and then that's times 10 to the 5th. And now I have to put it in scientific notation. Of course, I have kilometers per hour here. And I only get to have one number in front of the decimal.
Yes.
1.088
times
10. Let's see, moving left makes it larger. 1, 2, 3, 4. So did you get 10 to the 9?
No.
Oh dear.
Yeah.
Well, what did I do?
I think I made a mistake, Miss Gray.
Well,
let me see. 3.
Possible. We'll check.
Okay. Let's check it. 3. So 5 times 3,000. Yes, you're right.
Okay. Phew.
You're right, Ms. Ray. You're good.
We were following the rules for scientific notation.
Yes.
So we should end up with the right answer.
Well, because sometimes if you're going to use this, if you don't know how to put in the numbers, you get a wrong answer.
Well, that's one of the troubles. You think you can trust your calculator,
exactly,
but you can only trust it as much as you trust yourself to do it correctly.
Right. But I checked the answer. That's the correct answer. 1.08 times 10 to the power of 9.
Right.
Kilometers per hour.
My speedometer, 100 kilometers per hour, is about the same as 60 miles per hour.
Oh.
And this is like 1 billion kilometers per hour.
I can't get a speed ticket for that.
I don't think...
Because the police will not catch me.
Right, the police wouldn't catch you. But the trouble is at the speed of light, time starts to slow down and your mass begins to change, and so does your length. Yeah. So, you know, relativity takes over. And you wouldn't like it either.
Yes.
Yeah, even without a speeding ticket. All right, we have one more idea to talk about.
Okay.
This is how to use density in your t-table.
We just talked about density in the last podcast, right?
Right. So this is something you probably never considered before. You can change mass to volume, or you can change the volume to mass as long as you know your density.
Yes.
Because here's what we know. If we have a density of 12 grams per milliliter, that means for every 12 grams, you have 1 milliliter.
Yes.
That also means every 1 milliliter of that substance is going to have a mass of 12 grams. So you can write it upside down. Either way you need to get what you want.
Yes.
So let's try this.
Okay.
We're going to start with 6 grams. We want to end up with milliliters. Okay. So
and the density is 12 grams. Yep.
Right. So as always, I put 6 grams as my starting place because that's what they gave me to start off.
Yes.
Okay. They also told me the density. So I want to make sure that I have grams on the bottom and milliliters on the top because crisscross cancels.
Yes.
I had grams on top first. I got to go crisscross. So which of these conversion factors puts grams on the bottom?
It's the 1 milliliters over 12 grams.
Yes. 1 milliliter.
The one on the right.
Over 12 grams. And I don't think you'll need a calculator for this either.
No.
Because we get 6 times 1 is 6.
Divided by 12.
Divided by 12. And then grams has canceled. So I get milliliters. All right. Well, let's write this fraction in decimal form.
That's 1.5. Yeah.
Yeah. 1/2.
You said decimal point, yeah.
Yeah.
I'm talking about fraction.
Yeah. So
That's 1/2.
1/2 is 0.5 milliliters.
Yep.
That's it. We just did a T table for density.
Whoa, that's easy.
Yeah.
Pretty quick.
So you put the density in so that you can change what you have to what you want.
Exactly.
That's all.
All right. Is that the last one?
I believe so. Let's see. We're going to get our spinning thing.
All right. There you go, guys. We're done with
Unit 2?
Whoa.
I know. Time to study for that Unit 2 test.
Okay.
Study hard. We'll see you in class.
All right. Bye.